Hello, am I audible?
Good evening, sir.
Yeah, good evening. Then are there more students to join?
Yes, sir. I guess there are 10 or 11 of them to join.
All right. And what we have to do today?
Electromagnetic induction, sir.
EMI
Yes, sir.
questions, right?
Yes, sir.
Good. Okay, we'll wait till 6:05, then we'll start.
Okay, sir.
Hello, still more to come?
Yes,
Yes,
sir.
sir.
All right, wait for 2 minutes more. Okay, now shall we start?
Okay, sir.
All right. So we have to solve some questions related to electromagnetic inductions, right? Is it?
Yes, sir.
All right. So have you revised it? Have you revised it? Here. So we'll be starting with electromagnetic induction. And we'll be solving questions. Try to solve whatever you know, try to apply. After that, I'll be solving it. This is the first question we'll be starting with. A coil with an average diameter 0.02 meter is placed perpendicular to the magnetic field, and that magnetic field initially was 6,000 Tesla. If the induced EMF is 11 volts, when the magnetic field is changed to 4,000 Tesla in 4 seconds, that is the time. What is the number of turns in the coil? This is what you have to find. Try to solve this. Everyone? Do it fast. Any answers? No answers? Shall I solve it?
Okay.
Okay, sir.
All right. See here. So we have been given with the, first of all, EMF is what? N delta phi upon delta t, right? What is phi? Phi is magnetic field into area. Okay. In delta phi, what is the thing that is changing here? Is it magnetic field or is it area? It is magnetic field. You can see from 6,000 Tesla to 4,000 Tesla in 4 seconds. So I can write the same thing as N into A, B2 minus B1 upon T. What is N? So number of turns that is what we have to find basically. Okay, it is 11 volts. N into area is pi into r square 0.02 whole square into 6,000 minus 4,000 upon time, that is 4 seconds. Okay, so from here we need to find the value of N. N is what? 11 into, it will be 11 into 4. Okay, if I expand pi will be 22 upon 7. So 11 into 7 into 4, 7 into 4 divided by 22 into 0.02 whole square into 2000. If you solve this, you'll get 35. Understood or not, everyone?
Sir.
Understood, sir.
Good. Let us go for the next question. Next question says that flux varies with time as 5t cube plus 4t square plus 2t minus 5 Weber. This is flux, which is varying with time. All right. So you have to calculate the induced current. Calculate induced current at t is equals to 2 seconds. T is equals to 2 seconds. If resistance of coil is
So,
5 ohm. Yeah, any
so
doubt?
for the previous question, I got the answer as 70, sir.
70.
Sir, I think you substituted for radius, you have substituted diameter, sir. I think it should be by 2.
Oh yeah. Then no. Then if you do it, then 4 will go up. In that
Yes,
case,
sir, then
4
answer
will
will be
go
70.
up. In this case, it will be 1 minute. If you solve this, let me check it. So 11 2 2000. So 7 into 4 upon 4 into 10 to the power minus 4. 4 into 10 to the power minus 4 and into 1000. This 4 will get cancelled. Yeah, it will be 70. Correct. Sorry. My mistake. 70. All right. That was diameter. Correct. Not the radius. Now see the second next question. Try to solve this.
Sir, is the answer 15.6?
15.6 is the correct answer. That's correct. Anybody else with the same answer? Anybody else with the same answer? All right, I'll do it. So EMF is nothing but N into d phi by dt. Nothing is given about N, so we'll be considering it to be 1. So we'll just differentiate d phi by dt. Pi is, if you differentiate this, what will you be getting? It will be 15t square plus 8t plus 2. Okay, this will be EMF. So EMF at t is equals to 2 seconds will be what? So 15 into 4 plus 8 into 2 plus 2. So 60 plus 16 plus 2, 78. Now what is current? Current is E upon R. So E is 78 upon R is 5. You'll get 15.6 amperes. Everybody understood?
Sir.
Everyone? All right. Next question. A coil of mass, mean area 500 centimeter square, having 1000 turns, is held perpendicular to field of 0.4 Gauss. 0.4 Gauss. Okay. The coil is turned through 180 degrees in 1/10th of a second. All right. Calculate the average induced EMF. Calculate average induced EMF. But can you tell me what is Gauss?
So 10 power minus 4.
All
10
right,
power
very
minus
good.
4.
1 Gauss is 10 to the power minus 4 of Tesla. Now you can solve this. Very good. Everyone, Sanjay, Shiva, Subcharan, Sweta, Vishal, I need answers from everyone.
Sir, is the answer 2 microvolts, sir?
2 microvolts. No. Check it again. Two more minutes for this question.
Sir, is it 2 into 10 power minus 5?
No, you're getting too much. This value is not that much negative. Check your calculations again. It's a mistake you're doing. You have to calculate the EMF, and that is of the order 10 to the power minus 2, not more than that.
Sir, is it 500 centimeter square or meter square?
It is 500 centimeter square. See, 500 centimeter square. 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 500 centimeter square
Sir, and is it 0.02 volts?
No. Okay, let me solve this. See. Everyone, are you not solving? Rishi, are you there?
Yes, sir. I'm solving, sir.
Why not answering? Divya,
Sir,
everyone, come up with the answers. All right, see here. So basically, we have area as 500 centimeter square. So we can convert it into 500 into 10 to the power minus 4 meter square. Okay. Then we have magnetic field 0.4 Gauss. That is 0.4 into 10 to the power minus 4 Tesla. All right. And everything is there, right? So initial phi 1 BA cos of 0 because it is perpendicular. Okay. That is BA only. Phi 2 final. It is turned to 180 degree. So BA cos of 180 degree. So that will be minus BA because cos of 180 is minus 1. So what is change in flux? Delta phi. Phi 2 minus phi 1. That will be minus BA minus of plus BA. That will be minus of 2BA. EMF minus delta phi upon T. So minus of minus 2BA upon time. That is 1 by 10. So it will be 2 into B. What is the value of B? 0.4 into 10 to the power minus 4. Area is 500 into 10 to the power minus 4 divided by 1 by 10. So this 10 goes up. So it will be, okay, one more thing. Number of turns is also 1000. Number of turns is also 1000. So we'll be multiplying with 10 also. So into 1000 into 10 to the power 3. So it will be, this 10 goes up. So 10 to the power 4 into 0.8 into 500 into 10 to the power minus 8, if I'm not wrong. Isn't it? Do you agree with me?
Yes, sir.
All right. So it will be 0.8 into 10 to the power 4 into 500 into 10 to the power minus 8. So if you multiply the numerical values, you'll be getting what? 5
Sir, is
8s are 40.
Sir, is it 0.04?
Yeah, that is the correct answer. Into 10 raised to the power minus 4. So it will be 0.04 volts. That is the answer. Everybody got it or not?
Yes, sir.
Everyone? Jeffrey, Nandana, Santosh?
Yes, sir.
All right. Next question. Next question says that a magnetic field of flux density 10 Tesla acts normal to a 50 turn coil of 100 centimeter square. Find the EMF induced. In it if and the EMF induced in it if the coil is removed from field in 1 by 20 seconds. Do this.
Sir, is it 100 volts?
1 minute. Anybody else with the same answer? Hundred volts is correct. Basically, what you have to do in here, EMF is equals to minus N into A into B2 minus B1 upon T. Because A is not changing, so we have taken out of the change pattern. All right. So finally, our magnetic field is going to be 0. And initially it was 10 Tesla. So it will be N into A into B2 is 0, B1 will be 10. So minus minus plus into 10 upon T. T is 1 by 20. N is given, that is 50 turns. Area is 100 into 10 to the power minus 4 into 10 into 20. This 20 comes up. If you solve this, you'll get 100 volts. Right? Everyone, did you get
Sir,
it?
is flux density same as magnetic field?
Flux density is same as magnetic field. I think sometimes it is used
Because
preferably,
what
but
I thought is magnetic field units is Tesla, and for flux it will be Tesla meter square. But in the flux density, the SI unit uses just Tesla, so I thought maybe the meter square will get cancelled because it's density.
then it's sir area density, not the volumetric density.
Yes, so that was the confusion.
Mhm. You need to work upon this units. Sometimes they'll be using the words confusingly, just to confuse you.
Yes, sir.
You need to work upon the units. All right. Next question. 1 minute. I'm taking it from here. The next question is like this. Try to solve this. An aircraft with a wingspan of 40 meters flies with a speed of 1080 km per hour in eastward direction in northern hemisphere. The vertical component of Earth's magnetic field is 1.75 10 to the power minus 5 Tesla. Find the EMF or find the potential difference. What's that? Oh yeah, find the EMF that is developed between the tips of the wings. Do it. Any answers? Nobody? It's easy. Tejas? Am I audible? Anyone?
Yes, sir.
All right. So this one is easy. See, let us assume that this is our plane. All right. It has its wings.
0.21 volts, sir.
0.21.
21 volt.
That's correct. That's correct. 0.21 volts. That is correct. So this one is easy. Let us say that this is our airplane and this is flying horizontally, and perpendicular component of the magnetic field, Earth's magnetic field is going down like this. Okay. So we can assume that the movement is in forward direction, velocity, magnetic field is going down, and this is our length. So all three are perpendicular to each other, LV. So we know that EMF is equals to BLV. Okay. So magnetic field is given to us. That is the perpendicular vertical component of magnetic field. 1.75 into 10 to the power minus 5 Tesla. Length is given to us 40 meters, and velocity we have to convert it into SI unit. So 1080 into 5 upon 18. That will be 300 meter per second. So into 300. That will give you 0.21 volts. Everybody understood or not? All of
Sir.
you?
Yes, sir.
Good, good, good. One more question, like the same, it was there. I think the next one. Yeah, this one was there. 1 minute, I'll just copy it out. This question. This is also kind of same question. You just need to check the what perpendicular components of all of them. EMF is B into L into V, but all the three components should be perpendicular to each other. Okay, I'll give you a hint. I'll give you a hint. See here. Earlier, we had the plane. We had the plane. All right. And that was moving horizontal. Its velocity was v. The span is given to us. This is the span. And we need the vertical component of Earth's magnetic field, BV. But we are given with BH. All right. So I'll show you this. This is the graph. This is the magnetic field. This is the horizontal component. This is the vertical component. This is delta. Can you relate BH and BV by tan delta? Now try to solve. Tan delta will be what? BV by BH. So BV will be what? BH tan delta. Now this you can put it here. So EMF is BVL into V. So BV is BH into tan delta into length, that is 30 meters, into velocity is given 450 meter per second. So BH is how much? 4 into 10 to the power minus 4 into tan of 30 degrees into 30 into 450. From there you'll get the answer around 3.12 volts. Did you understand it, everyone? Tell me, everyone, did you understand it or not?
Sir.
Yes, sir.
All right. Next question. If a 10-meter long metallic 10-meter long metallic bar moves in a direction, metallic bar moves in a direction, at right angle to magnetic field, at right angle to magnetic field. With a speed of 5 meter per second, 25 volt EMF is induced. EMF is induced. Okay. Find the value of magnetic field intensity. Find the value of magnetic field intensity. So this 2 minutes more, I'll be waiting. All right. See here. All right. See here, everyone. So this is very easy. EMF induced is B into L into V, right? EMF induced is B into L into V, right? So we have been given with the magnetic field. All right. Find the value of. We need to find the magnetic field. Rest everything is given. So B is equals to what? E upon LV. EMF induced is 25. Length is 10 meters and velocity is 5. This is easy. Why are you not solving questions? 0.5 Tesla. Understood or not, everyone? Please respond. Did you understand it or not? Rishi? All right.
Sir, I got it, sir.
Okay, next question. A circular coil of area. Okay, I have this question. 1 minute. I have this question, I guess. Yeah. Yeah, try to solve this question. A circular coil of area 300 centimeters square and 25 turns rotates about its vertical axis with an angular speed of 40 second inverse. In horizontal magnetic field of magnitude that is given, obtain the maximum voltage induced in the coil. Try to solve this. Please try to solve. Otherwise, how would you get it? Did you get it? Mitran? Any answer? Am I audible?
Yes, sir.
Why not responding? Okay, see here. This one is also easy. So we have been given with the area. Area is 300 centimeter square. That is 300 into 10 to the power minus 4 meter square. All right. Then what else we have been given with? We have been given with omega, that is 40 second inverse. Magnetic field is 0.05 Tesla. Okay. So basically, EMF is what? E naught sine omega t. And what is this E naught? It is NBA omega. That is the maximum value when you put sine omega t as 1, because this is the maximum value you can get any sine function. So maximum value of E is E naught, that is NBA omega. You just put the values. So number of turns 25, N is 25. Magnetic field 0.05. Area 300 into 10 to the power minus 4. And then omega, that is 40 second inverse. So if you put this value together, you'll be getting 1.5 volts. Understood or not, everyone?
Sir.
All right. So this was all from my side. You need to solve more questions and you need to participate. If you won't do that, you will be at trouble then. Try to solve more questions, as much questions as you can, and get yourself down cleared. Okay? If you don't have any doubt, shall we end it up here?
No doubt, sir.
No
All
doubt,
right
sir.
then.
No doubt,
Thank
sir.
you.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.